As we transition to a greener grid, more distributed energy resources are being connected to the distribution grid. As more is installed, we need to be able to identify their locations and electrical connectivity to keep the grid running reliably. We need to make sure that distribution transformers, conductors, and other equipment are sized adequately for these new power flows. That's where our friends from FutureGrid come in. By analyzing vast amounts of meter data and other data, FutureGrid is helping utilities gain better insights as to what is installed and where.
The world is moving to a cleaner, greener energy supply. And Australia is no stranger to this transition, with some of the highest per capita rates of rooftop solar in the world. Some of our customers have nearly 50% in their network. And so the challenges this brings to distribution operators is often voltage or hosting capacity management of assets that are currently invisible. And FutureGrid is software that makes these invisible assets and part of your network visible. And we do this using AMI 2.0 information, combine this with GIS data, and on a moment-to-moment basis update information about the state of the secondary network. So for example, with Fortis BC, after their deployment, we're able to see a number of data quality challenges in the GIS data, which we're able to identify, and they were able to resolve. But more importantly, once they had the voltage view of their secondary network, understand the impacts of augmentation or changes they've made down at a consumer level like they've never seen before. Another interesting phenomenon we discovered during the demo program was that in North America, meters can report multiple voltages because of your phase-to-phase arrangements. And so FutureGrid was modified and augmented to enable this multi-phase visualization. So you can aggregate and understand voltages depending on which voltage level you're interested in. Later through the project, we deployed what we call hosting capacity visualization and analytics, and that is to provide hosting capacity assessments of low voltage assets such as transformers. And this was able to quickly pick up a number of low voltage assets and transformers that are heavily utilized or didn't have much capacity. Now, for example, from an investment planning perspective, asset planners can easily understand where their investment strategies need to be targeted. And they were all able to do this during this program.
It was quite easy to begin visualizing and analyzing our AMI data. We sent FutureGrid an extract of our hourly meter data and GIS distribution network topology data, and within a few weeks we started to see results. This has helped us identify minimum and maximum voltage excursions, instances of transformer overloading, and has provided a more granular view of distributed customer generation and its potential impact on a station feeder or a section of a feeder. In the future, we're hoping to use these types of tools to increase our visibility of customer power quality, particularly when we're doing system work or reconfigurations, as well as to identify and monitor specific types of loads, including electric vehicles, distributed generation. Thanks to the FutureGrid team, they've been great to deal with. Real cool bunch of guys.
We look forward to working with other North American utilities as we scale out our technology into North America. And we see FutureGrid as being a new component or a new ingredient of your energy distribution supply management landscape.